Hello students, 7 chapters, 10 different concepts and 10 different formulae were used to solve a single problem, and such a problem was asked in NEET 2025. Okay, in this video let us see what that problem is, how to solve that problem, and if you are preparing for NEET and JEE, how to mold your preparation such that you don't miss out the marks on such multi-concept problems. Okay, you can't get more multi-concept than this. Let us get into the problem. Let us see first what does the problem say. The problem says a model for a quantized motion of an electron in a uniform magnetic field B states that the flux passing through the orbit of the electron is NH by E. What does that mean, sir? Half the students didn't even understand what the question means. That's the reason why they have even they didn't even bother to solve the question further. Okay, let me translate whatever he's saying into very simple language. Okay, so what he says is there is a magnetic field. In that magnetic field an electron is moving in a circular path. You may ask, sir, where did he say that? Where did he say that the electron is moving in a circular path? If you actually read the question carefully, he actually said that. You see, didn't he say that uniform magnetic field B? Yes, he said that. Didn't he say that the orbit of the electron? Yes, he said that. So by combining these two, we have to link that, if there is a uniform magnetic field and we know that a charged particle in a uniform magnetic field takes a circular path. We know that, and electron is the charged particle, there is a uniform magnetic field, and he said it is in orbit, so therefore it's moving in a circular path. That we have to understand. So just from that statement you need to be able to draw this picture. If you are unable to draw that is where your conceptual clarity lacks. Okay, now he says he just didn't say that, he said something else in the same statement. The flux passing through the orbit of the electron is NH by E, which means he's talking about the magnetic flux. We know magnetic flux, right? A magnetic flux phi. First let me write what he has given. He has given the magnetic flux. Okay, he has given the magnetic flux is equal to NH by E, where N is, he only said, where N is an integer, H is the Planck's constant, and E is the charge of the electron, magnitude of the charge of the electron. That's what all of that was given. Okay, so the flux phi is equal to NH by E, he has said, sir. Now what do we need to find? Let us see first what do we need to find. According to the model, the magnetic moment of the electron in its lowest energy state will be, he said, magnetic moment of the electron. What is magnetic moment of the electron? We usually denote the magnetic moment with the letter mu. So we are supposed to calculate what is the value of mu. Mu is how much, right? So what is mu, sir? Mu we know, but mu is usually calculated for what? You tell me. Mu, magnetic moment, is calculated for a current carrying loop, right? If there is a current carrying loop, then we know that the magnetic moment of that is defined as I into A, where I is the current in that loop and A is the area of that loop. But here, where is the current carrying loop? There is no current carrying loop. There is an electron which is moving in a circular path. There is no current carrying loop. But what you should know before going to the exam hall is that we have already studied this in atomic structure, we have studied in electromagnetic induction, we have studied this in moving charges and magnetism, we have studied this, that a charged particle, any charged particle for that matter, moving in a circular path can also be treated as a current carrying wire. How, sir? Why is that? See, you don't need a wire. Current is nothing but what? Current is nothing but rate of flow of charge. See, here is the charge and the charge is moving in a circular path, yes or no? So there is a loop and there is a charge, it is flowing, so therefore there is current. Current is nothing but rate of flow of charge and it's a loop, so therefore current carrying loop. There is current and there is a loop, right? So all that you need to find out is what is this A and what is this current. A is, I think, very simple. A is the area of the loop. Area is equal to pi r square. Our first formula, well actually this is the second formula. The first formula was mu is equal to I times A. Okay, now all that you need to find out is what is I. What is the current I, sir? The current I you need to calculate from this. So let us say the current I, and the current is equal to how much, sir? Current is equal to, current is rate of flow of charge Q by T from the current electricity chapter. So Q is the charge of the electron, and T is what, sir? If a single charged particle is moving in a circular path, then T is the time it takes for it to cross the cross section again. Okay, cross the cross section again. What is that time period? That time is nothing but the time it takes to complete the whole circle and come back to this point. Yes or no? Okay. So how much time does it take to cross this point once again? That will be the time period, sir. Time period of this circular motion. So which means we are now in circular motion chapter. We are talking about circular motion. What is the time period? The time period is equal to, time period is equal to distance by the time taken for it to travel this entire path. That will be is equal to 2 pi r, that is the distance traveled by the speed of this particle. Let us say the speed is v. Okay, so that will be your 2 pi r by v. Let me directly substitute it over there. Then that is E by 2 pi r by v. So that will be equal to EV by 2 pi r. This is your current. So I have successfully found the current also. Let me substitute that over here, sir. So mu is equal to EV by 2 pi r into EV by 2 pi r into pi r square. So pi gets cancelled, r gets cancelled. So it is EVR by 2. Understood? Let me write it slightly differently. It is E by 2 into V into R. Yes or no? I just have rewritten in different format. Now, the question here is, what is the value of V and what is the value of R? Because in the problem, he never stated that the speed of the electron is V, and he never stated that radius of the path is R. He didn't say anything about that. He has in neither any of the options contains these terms. So which means we need to eliminate V and R. The speed we have to find out and the radius of the path we need to find out. Now the question comes, how do we find out the V? How do we find out the speed? Let me see. This is a circular path. All that we know is that it is moving in a circular path. If any particle is moving in a circular path, what do we know, sir? That there must be some centripetal force that is acting on it. Yes, and that centripetal force will be is equal to mv square by r. There is our V. So if there is a centripetal force that is acting, that centripetal force should be equal to mv square by r. But in this case, in the case of charged particle moving in a magnetic field, how much is that centripetal force? Who is exerting that centripetal force? Who is exerting? See, you and I are not holding the electron and moving it like agarbatti. No, we are not moving. So someone is holding the electron and moving it. Who? It's the magnetic field. There is no one else to move the electron. So the magnetic field is exerting a force on the charged particle, and that is equal to mv square by r. Okay. And how much is that force, sir? That force is equal to the force exerted by a charged particle, by a magnetic field on a charged particle, is q v bar cross b bar, but we can simply write q vb. That's the magnitude of the force, because v and b are perpendicular. Only then the circular motion will happen, right? So in other words, what I can say is q vb, whereas q is, what is the q value here? Q is the E. The E is the charge of the electron. EVB is equal to mv square by r. This is my second equation, and from this what do I get? I get 1 v gets cancelled, so v is equal to EBR by m. EBR by m. I can substitute, I can get that mu and substitute in my original mu. So let me substitute that. Mu is equal to E times of EBR by m times r. So that is E square b by m into r square, right? Into r square. Now, how do I find? So, what I have successfully managed to do from this step to this step is I have found V from the centripetal force equation and I have substituted it here. I have eliminated V. See, this was the problem, right? We needed to find what is V and what is R. And we have successfully eliminated the V. Now, the question only remains, how do I get the R value? How do I get this R value? Where do I get the R? In fact, if you read the problem, this was a given piece of information. And until now, we haven't actually used this piece of information. Okay. So let me use that piece of information, right? What was given? Let me rewrite that. Given the flux phi is equal to NH by E. Okay, that is flux phi. But what is flux, sir? Flux is, we know, like, if there is a current carrying, if there is any loop, and if there is a magnetic field that passes through it, then the flux phi through that loop is equal to B bar dot A bar. We have studied this in electromagnetic induction. Okay, we are now in electromagnetic induction. So B and A are in the same direction. So it will simply be B dot BA will be equal to NH by E, where A is the area of the loop. And in this case, the area of the loop is, here magnetic field is going through this loop. Okay, so that will be equal to B into pi R square is equal to NH by E. And from here I can get the R square value, NH by E B pi. Let me get this R square and let me substitute it over here. So mu is equal to E square B by M into NH by EB pi. E gets cancelled, BB gets cancelled. So what do we get? This will be equal to NH E by pi M. This is what you get. Okay. So therefore mu is equal to mu, the magnetic moment, is equal to NHE by pi M. Are we done, sir? I think we should be done. This is what he wanted. Mu is what he wanted, and we have calculated. Mu is what he wanted, and we have calculated the mu by calculating the current and by calculating the area. And as you can see here, there are no other terms. Are we happy? Are we happy? No, because that is precisely not what he is asking. What he is asking is the magnetic moment of an electron in its lowest energy state. There is one more piece of thing. We need this moment in its lowest energy state. How do I get the lowest energy state? Here there is a letter which is N. You see this N? Okay. And what did he say about N? N is an integer, is what he said. What does that integer mean? There is an electron. It is saying that it is moving in an orbit. And he said that this is quantized model. What should that tell us? This should be the quantum number. This should be the principal quantum number, and principal quantum number N is equal to 1. That is what is actually what corresponds to mu, lowest energy state. So therefore, what will I write? For lowest energy state, lowest energy state N is equal to 1. So therefore, mu is equal to EH or HE by pi M. This is our final answer, and that is given in HE by, I think, HE by 2 pi M. Actually, we are supposed to get 2 pi M. Probably we have eliminated. Oh, there is a 2 here. Actually, it is E by 2. I forgot to write E by 2 all the way in all the terms. So there is a 2, there is a 2, there is a 2, there is a 2, there is a 2. Okay, EH by 2 pi M. So therefore, the second option is the correct answer. Okay. Now coming to the lessons. Okay, sir, all of this is fine. Just look at all the formulas that we have used to solve this problem. Area is pi r square. The perimeter distance by time, it is 2 pi r by m. speed is equal to distance by time. From kinematics chapter, the time period is equal to 2 pi r by v. From the circular motions, from the circular motion, the centripetal force is equal to mv square by r. From current electricity chapter, the current is equal to q by t. Force on a charged particle is q v cross b. Magnetic moment is I into a. Flux is equal to b bar dot a bar. And finally, from the atomic structure, that lowest energy state corresponds to a principal quantum number of n is equal to 1. See, these are all the 10 concepts that we will had to use to just solve this problem. Just imagine, you knew 9 out of this 10 chapter, 10 concepts. Would you be able to solve and get the answer to this problem? No, right? No. That is what this problem actually requires. So what is the important lesson number 1? If you are preparing for NEET or JEE, such problems could be asked, very well asked, not just in NEET, they are usually more commonly asked in JEE mains also. So if you are preparing for JEE or NEET, the very important thing is never ever skip any chapter. But actually, if you look at this, none of these formulae are individually complicated. They are all simple. None of these concepts, these are all very basic fundamental formulae. Speed is equal to distance by time is not some complex kinematics problem formula, right? It's a very simple, the basic 101 type formula. So you needed to recollect all of this in the exam form when you are solving there. Sorry, before going there, I want to complete my earlier point that even if you missed such simple formulae, let us say you don't like rotational mechanics, a lot of students don't understand mechanics very well. So what do? They just skip them. Some chapters, okay, I don't know this rotational mechanics, I don't know, I'll leave it. Or some concept from some chapter, from surface tension, I don't know something, from Young's modulus, from properties of matter, I don't know something, I'll leave it. Don't do such things, because if you do, even if you know the rest of it, you will still won't get marks in such multi-concept problems because you didn't remember that basic thing. That is lesson number 1. And what is lesson number 2, sir? Lesson number 2 is, even if you know all the 10 formulas, it's not sufficient. In that exam hall, when you are sitting, in that 2 to 3 minutes time, when you are under the exam pressure, you should be able to recollect from this chapter, from class 11, from inter first year, from this chapter, from that chapter. You need to gather all of that and arrive at the solution, and that won't automatically come. For that, you need to have very rigorous practice. What I see often, the biggest mistake that students make while preparing is that they are going to do a lot of typed problems, like, oh, this type of problems, okay, this concept problems, 20 problems. That is necessary. I'm not saying that that is bad, but that is necessary but not sufficient. For you to not miss out on questions like this, the important lesson number 2 is you need to solve lot of multi-concept problems. If you didn't do it, then you are going to lose marks. So in this channel, I'm going to take a deep dive into a lot of such analytical deep dive into a lot of JEE and NEET based problems. Okay, NEET problems. So subscribe to the channel so that you don't miss on the updates, and it will help you in your preparation. And see you in the next video.